Welcome back to GATEX AIML. So today we'll start with the new concept, that is overview of discrete probability distributions. In the previous video, we have discussed about the random variable and different types of random variables, that is discrete and continuous random variables. Now we will try to and also we have seen the basic overview or understanding of what a probability distribution means. So in this video, we'll go and try to understand the discrete probability distribution. Okay. A discrete probability distribution describes the probability that discrete random variable takes each of its possible values. So when I explain the distribution, I explain that if you have a sample outcome, you have a sample space, and then say that you have a sample outcome. So say 0, 1, 2, 3, and 4. So for the outcomes, you are going to assign certain probability. So you denote it by P of x equal to 0. This is P of x equal to 1. So basically distribution means what? See, there are possible outcomes. For each possible outcome, you are going to assign certain probability value. So your entire probability value, that is 1, total is 1, right? Across your sample space, that is distributed among different random variables. Now we'll try to understand what is this probability mass function. See, for a discrete probability distribution, we call it as a probability mass function. The probability distribution is called as probability mass function. It has to follow certain rules. Okay, to become eligible for probability mass function, probability mass function is for discrete random variable. So what it says, let us say f of x that is given here is a probability mass function. When can we say or establish this as a f of x as a probability mass function is, it has to follow these three conditions. You no need to mug up any formulas or any mathematical notations here. Just try to understand the concepts. In your problems also, when you solve, if you know the concept, then you can easily solve it without applying any formulas or using these notations. So only thing is just focus and understand the concept. So what is the first condition? F of x should be greater than equal to 0. See, basically what I am saying, this f of x is nothing but this probability at that sample space. So for example, probability of x equal to 1. So that is nothing but f of 1. That is what I am writing. So this should be greater than equal to 0. So obviously it will be greater than or equal to 0. Why? The probability values are greater than or equal to 0. That is the first condition. Second condition, the sum of all the probabilities attached to each of the samples, okay, or each of the outcome should be equal to 1. So the entire total probability is 1, right? So at any point you take and add those, summation of x means for all x, okay, here in this case 0, 1, 2, 3, 4 in this example, if I add them, okay, x equal to 0, 1, 2, 3, that is f of x should be equal to 1. Okay, once you take the example, you'll understand. Then p of x equal to x is equal to f of x. That is what we have assumed here. Okay. So let us take this example and try to find the probability mass function and then verify whether it's a probability mass function or not. Okay. Let x be the number of heads observed when a fair coin is tossed 3 times. So let us write all the outcomes. Head, 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 head. Then you have head, head, tail. Then you have head, tail, head. Then you have head, tail, tail. Then you have tail, head, head. Then you have tail, head, tail. Then you have tail, tail, head. Then all tail, tail, tail. So these are the 8 outcomes. Okay. So now, what is the question? Number of heads observed in when a fair coin is tossed. Let x be a random variable. Okay. Which says number of heads in a coin toss, and it is tossed 3 times. Now, so what are the possible values of x? X is equal to 0 heads, can be 0 heads, it can be 1 head, 2 head, or 3 head. Maximum is 3 because we are passing it only 3 times. So let us represent it on this number line. So 0, 1, 2, 3, okay, 3 last. So the entire probability is 1. Now you attach the probability to each of this. This is what P of x equal to 0. The distribution. P of x equal to 1. This is P of x equal to 2. Then this is P of x equal to 3. Now you have to calculate the values. So the PMF, the probability mass function, also called as in short as PMF, is usually given in a table format. Okay. What are the contents of this table? X, that is the different values it takes, the random variable. Then what is P of x equal to x? So 0, 1, 2, 3. So these are the possible values it can take. So this x equal to 0 means what? You are saying 0 heads. How many combinations? Only 1. This is the one with 0 heads. So what is the probability of getting 0 heads is 1 by 8. Then probability of getting only 1 head, that is exactly 1 head. Count them. So here 1, then 2, and then 3. So 3 by 8. Probability of getting exactly 2 heads. So this 1, 2, 3. Again 3 by 8. Probability of getting all the 3 heads. So all the 3 heads is only 1. Right? So this is 1 by 8. This is the table what you have written here is called as the probability mass function. Now you have to verify the whether it's PMF or not. There are 3 conditions you have. The first condition was the f of x should be greater than or equal to 0. The f of x means what? This is what is f of x I am saying, that's it. So when I say f of x, x is can be 0, 1, 2, 3 here in this example. So the probability values should be greater than or equal to 0. If you observe here, all these values are greater than 0. So the first condition is satisfied. What is the second condition? Summation of x for all x, f of x, that is sum of all the probability should be equal to 1. This is the axiom of probability, right? So this is equal to 1 by 8 when x is 0. When x is 1, it is 3 by 8. When x is 2, it is 3 by 8. When x is 3, it is 1 by 8. If you add all those things, you will get 8 by 8, that is equal to 1. Therefore, this condition is also satisfied. The third one is P of x equal to x is f of x. This is what we have assumed. Therefore, whatever you calculated PMF is a valid PMF, probability mass function. So this is the concept of discrete probability distribution, that is probability mass function. We take one more example. A school buys 2 laptops at random from a shipment of 20 where 3 are defective. Let x be number of defectives selected. Now, there are 20 laptops in the shipments. Okay, so a school wants to buy 2. Out of these 20, what they are saying, 3 are defective plus 17 are say non-defective. Now x is a random variable which says number of defectives selected. So when I buy laptop, what will be the x values? 2 laptops I am buying. 0 can be defective, 1 laptop can be defective, or maximum 2 laptops can be defective. Now, how will you find the PMF for this probability mass function? Again, go for the table format. This is x, this is f of x or P of x equal to x. And write it as f of x. Okay, both are same. Next, x can take 0, 1, 2. Now, P of x equal to 0. that is nothing but f of 0 is equal to, that means 0 defective. So I have to choose two laptops. 20C2 is the denominator. Then in the numerator, all the laptops that I buy, two laptops should be defective. That means what? I have to choose from this 17 non-defective laptops so that there are no defective. 17C2. This comes out to be 136 divided by 190. Okay. Next, P of, so let us write it here, 136 divided by 190. Then P of x equal to 1 is f of 1. This is nothing but one defective. One defective means, so I am selecting two laptops. In that 3C1 out of 3, I have to choose 1 into 17C1, 1 from non-defective. So this comes out to be 51 divided by 190. Next, P of x equal to 2. This is nothing but f of 2. Both are defective. That means 3C2 divided by 20C2. So this comes out to be 3 by 190. So this is our PMF. Now, first check the condition. What is the first condition to be checked? F of x should be greater than or equal to 0. So all the probability values are greater than or equal to 0. Second is summation x f of x. Sum of all the probability should be equal to 1. If you add this 136 plus 50, 1 plus 3, it is 190. 190 by 190 is 1. This is also satisfied. Then already I assume P of x equal to x is f of x. The third condition is also satisfied. So therefore, this is a valid PMF table. Okay, hope you understood this. Now, there is a concept called as cumulative probability distribution. Okay, so CDF can be applied for both discrete as well as continuous variables. So here we will see cumulative distribution or cumulative probability distribution for discrete variables, random variables. Now, what is this CDF? Cumulative means what? For example, you will get in your marks card, right? If you are following a grade system, so out of 10 you will get 9 in semester 1, 8.5 in semester 2. So usually semester they will give grades, also they will give CGPA, that is cumulative grade point average. Cumulative means what? They will go on adding your grades or the points for every semester. So that is cumulative. So similarly here, cumulative means you will take sum at all the points. So for example, let us say, so this is x, this is x equal to 0, 1, 2, 3, and 4. Now, this point is P of x equal to 0, go on up to this is P of x equal to 4. So what this cumulation says is represented by capital F of x in general. Small f of x is probability distribution, capital F of x is cumulative distribution function of random variable x. How it is represented? It is equal to P of x is less than or equal to x. Okay. If I take for example f of 3, this one f of 3 is here. What it says, till this point you add all the cumulative, that is add all these points. So f of 3 is nothing but P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3. This is what is cumulation till this point. So how it is represented mathematically? So summation of t less than or equal to x f of t. For example, what is 3? So 3 is t here. So till you reach 3, you take all f of t. F of t is your probability distribution. P of x equal to 0, P of x equal to 1, plus P of x equal to 2, plus P of x equal to 3. Okay. So from that to x. So t starts from 0, 1, 2, and then less than or equal to x. X is 3 I have chosen here, no? This 3. For all this probability, f of x, you add it. Once I take examples, you'll understand. So what are the properties? F of x is non-decreasing. Why? See, I'm adding these probability values. So every time I add certain value, it will not decrease. Automatically, it may or may not increase. It will be non-decreasing. Okay, it will never decrease, because some of the probabilities I am adding every time. Then limit of x tends to minus infinity, f of x equal to 0. Plus infinity, when it tends to plus infinity, it is 1. In a line, they are saying that this is 0. The values can be from minus infinity to plus infinity. So this side represents 0. This side represents 1. When I explain the limits concept, I will explain in detail what is the concept of this minus and plus infinity. As of now, you can take probabilities tending to minus infinity is 0, tending to plus infinity is 1. In the problem, basically, they will give a boundary. Minus infinity means what? This is one boundary, this is another boundary. So, for in this example, it is 0 and 4. So, these two we'll see later. Next, let us take an example of the CDF. They are given the probability distribution or probability mass function values here. Okay, 0, 1, 2, 3, 4. How will you calculate the CDF? F of 0 means what? So let us say 0, 1, 2, 3, and then 4. F of 0 means it is equal to P of 0. P of x equal to 0. Why? This is the first point. There is no cumulation here. No? In the beginning, there will be no cumulation. This is the first starting point. Then, what is f of 1? F of 1 equal to P of x equal to 0. This point plus this point. So that is f of 1, cumulation of 2. Next, similarly, f of 2 is equal to this f of this P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. Similarly, P of f of 3 and f of 4. So that is how you write the cumulative distribution function. It is represented as in capital F of x in my textbook, and then usually this is standard notation. Cumulative distribution function means P of x is less than or equal to x. See, f of x is equal to P of x is equal to x. This is what? Probability mass function of a discrete random variable. If I write capital F of x, that is equal to P of, you should write x less than or equal to x. Okay. So this is what CDF for a continuous or discrete random variable, DRV. How is the CDF plot? How it looks like? It is called as a step function. It is not a continuous curve. Step function. Why it is step function? Because it is discrete. So when the x equal to 1, you have probability of 0.1. When x equal to 2, you have probability of 0.3. 0.3 is coming from cumulative, okay? 0.1 plus 0.2, like that. So this is how it looks, step function. Let us take one more example. Coin toss 3 times. So already I have seen this, right? First example only. So how will you find the PMF? They already given the PMF of x here. So next, with that, how will you find the CDF of x? So in the previous you have found the PMF. You have got the PMF. Now CDF is same thing. F of x 0 equal to P of x equal to 0. F of 1 is, you can write f of 0 plus x of 1. See, you can write like this also. No, this is the previous value. Cumulative means what? If I am finding, say, f of 3, the previous till this point is f of 2. So f of 2 plus this P of x equal to 3. This point is x equal to 3. This is complete cumulative. Okay. Similarly, these rules we'll see. So P of x greater than 1 means what? So for example, say that this is 0, this is 1, this is 2. I'm saying x greater than 0 means not this point. So greater than 1. So greater than 1 they are saying x is greater than 1 means you are saying this point. How will you get this point? This point how will you get? This entire probability is 1. So if I subtract 1 minus, okay, f of 1 till this whatever I occupied, this all points within this range minus this entire value will give me what? The x greater than 1, this area. Okay. So here we cannot consider the entire line because it is discrete. In continuous you can see, I'll explain you. There you can consider. There this value changes. But here it's a discrete means this point, this point, this point. Only points we are dealing with, not lines. Okay. Line is for just a representation here. So how is the step function for this plot? You can observe here. When it is 0, it is 0.13. When it is 1, it is 0.5. Accumulation. Addition going on, doing addition. Why the CDF is required? CDF, basically when you model the problems, most of the time you will be using the CDF. Okay. Most of the time you will be using the CDF for mathematical modeling of statistics. Now we'll see the different, they are not the rules, but when the problems are asked in the exams, you should be very careful, like what is that they are asking, how to find those values. The first one is P of x is less than or equal to A. So let us say in that case it should be f of A less than A equal to means. So let us say the example, CDF P of x is less than or equal to 2 is a CDF given for you. So how will you find this? This is f of 2, this position they are given, and this is f of 0. So what is that you want to find? Less than or equal to 2 means all these points, 1, 2, 3, all these points you have to add. This is nothing but what? P of x equal to 0 plus x equal to 1 plus x equal to 2. This point, and this point. What these points represent actually? They are probability mass functions, right? P of x equal to 0. This point indicates P of x equal to 1. This point indicates P of x equal to 2. So if you add all these discrete points, you will get f of 2, right? That is what it says. Next. There it was less than or equal to A. Here it is less than A. Less than A means what? See, this is not a continuous curve. That's what you be very careful. It's a discrete. See, when I say P of x less than 2 and P of x less than or equal to 2, both are different. When I say x less than or equal to 2 means 2 is also included. That means this is the point. 2 is also included. This point is included. When I say less than 2, see it is discrete. Means what? When I say P of x less than 2, what is that I am trying to say? What is the number below 2? It is not continuous, right? If it was continuous, I can say that x tends to 2. That is 1.999 something like that. But here it's an integer. So what is the previous integer? This is 1. So that means what? This is as good as saying P of x is less than or equal to 1. So you should not consider this point till only this point. So that value will be P of x equal to 0. I have to add this and this, not this, because it is strictly less. Hope you are getting it. But in continuous case, don't get confused when I explain that. We will change it. It changes. Next, similarly, x greater than A. Let us say P of x is greater than 1. See, I have given it as a formulas. Please don't mug up them. Please try to understand what I am explaining. When question is asked something like this, find P of x is greater than 2. What is that you have to find out? Okay, this is important. Which one will add, which one will subtract, and which one will include, and which point will exclude. That is what you have to understand. So you need not mug up the formula. If you mug up, you will get confused. So P of x greater than 1. That means what? They are saying strictly greater than 1. That means what? It has to start from 2 and 3. So if this is 1, the entire probability is 1. They have mentioned it here 1. So it will be 1 minus. What is that you have to subtract here? What is that you have to subtract here? So definitely greater than 1 means this point is included, this point is included, this point is not included. So subtract p of x equal to 0 plus p of x equal to 1. That means what? So this part here they are asking. So this part you have to subtract from 1. Then we will get this part. That is how you have to visualize. Next. If x is greater than or equal to a. Okay. So in this example, they are saying p of x is greater than or equal to 2. So they are saying equal to 2. They are mentioning already equal to 2. And what is that you have to subtract? So this point is included already. This point is already included. So greater than or equal to means I included this point. Now what are the points left? This point and this point. So from 1, I have to subtract these 2 points. Right? Okay. So we'll get the p of x greater than or equal to a. So what is this? Using CDF you can solve it. No, 1 minus p of x equal to 0 plus p of x equal to 1 means what? It is f of 1. Right? So in the exam sometimes they'll give these values or directly they'll give the CDF value. So always it's not that they'll give the PMF. They may give CDF and ask you to find the probability value. So you should be careful. Like this is how the interconversion happens, right? That's why I'm explaining with all these line diagrams. Next, if it is in an interval, there are two intervals now, A and B. Both the x should lie between A and B, both included because less than or equal to. So P of 1 is less than or equal to x less than or equal to 2. So the 1 should lie between 1 and 2. So equal to means what? So that point is included. Less than or equal to means 2 is included. Then less than or equal to 1 means 1 is included. Okay, so I am finding the between these two. How will you find? This is nothing but what? F of 2 p. Calculate till this. Calculate till this. If you subtract this from this, you will get this, right? It's simple mathematics. Using the line, it's simple to understand, so I'm doing it. So f of 2 minus f of 0. So f of 2 means what? P of x equal to 0, 1, 2. This entire thing. Then this thing will give you this value. So it's already given here. 0, 1, 2 minus p of x equal to 0. Because this 1 is already included here. That's why I will not consider 1. I will consider 0. Next. Now the same case, if it is strictly greater than a, x is strictly greater than a. That means what? For example, in this example, we are asking 1 strictly greater than x less than or equal to 2. If 2 is included, but 1 is not included. So in that case, what I should subtract? So f2 I have to take, and then 1 is not included, so this comes under this, and then subtract from this. So f2 minus f1. f2 means what? P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. From this, you subtract f of 1. f of 1 means P of x equal to 0 plus P of x equal to 1. Okay. Next. Same case, this B is strictly less now. So P of 1 is less than or equal to x less than 3, not equal to 3. The less than 3 means what? Strictly less means the next point is 2, previous point. Okay, so f of 2 is this. So f of 2 minus, I have to less than or equal to 1. So less than or equal to 1 means 1 is also included. So I have to go for the previous one, f of 0. So that will give you this value. Next, strictly less now, both cases. Both the intervals are strictly less, not included cases. So 0, x less than 3. So they are saying less than 3 means definitely 2. No, 3 is not included. Then greater than 0 means what? Should be 1. Right? So here, don't get confused. Greater than 0 means what? This point should be subtracted. That is the meaning here. So f of 2 minus f of 0. Greater than 0 means from here to here. Next, the simple case, f of x equal to a. If I want to find x equal to 2 exactly, in some questions they may give, they will not give this PMF. They will ask you to find this PMF giving this CDF. So CDF is given for you. How will you find the PMF? So you can use this rule. So what it says, P of x equal to 1 is f of 2. This is what I have to find. So exactly this point I have to find means I have to subtract the previous cumulation. See, f of 2 is cumulative of what? F of 1, right, plus P of x equal to 2. This is your cumulation function. So P of x equal to 2 means what? F of 2 minus f of 1. This is how we calculate, right? So this is f of 1. So that is the basic understanding and some rules. How to identify CDF, how to identify PMF and calculate those values. So most of the problems they will be asking such a kind of things. Find x is greater than or equal to 2, less than or equal to 3, like that. Okay. So in the next video, we'll start with the continuous probability distribution with examples. Okay. So thank you for watching.